All right, we're ready for our next set of notes. We finished up notes on intercepts and graphing with tables. Now we move on to what usually everybody remembers with graphing linear equations, and that's with slope. So we're going to talk about rate of change and slope today with linear equations. A slope basically always means comparing a change in one variable to a change in another variable. So if we want to do the definition here of a slope, that would be comparing the change in one variable to change in the other variable. And we say this in lots of different ways. One way we've seen it before is we'll see it written the change in y, and a triangle like that, it's a delta, but it means change in math. So change in y over change in x. Or we may also write it as rise over run. That's probably a lot of how you remember learning about it was rise over run, right? The rise is how much we change up and down. The run is how much we change horizontally or left to right. And then we've actually got a formula to find that change. If I want to find the change in two y values, then I'm going to take one of my y values, and usually we see it written y2 or y sub 2, and we subtract the other y value, so y sub 1. And then on the bottom, to find the change in the x values, we do x sub 2 minus x sub 1. That is basically your slope formula. We use an m to denote slope, so you'll see that always equal to m. Know that formula. You've got to know it. We'll use it a lot over the next several years. Okay, so then to kind of see a couple examples and how this works, we're going to start with our first example here. And I'm going to start just by plotting these 2 points. So we want to graph a line that passes through negative 2, 2, and 3, 4. So I'm going to plot those 2 points on my graph. So if I go to negative 2 and then 2, that's right there. And then I'm going to plot the point 3, 4. So 1, 2, 3, 2, 3, 4. That's right there, right? And then once I have 2 points, that's enough to draw a line. So I can graph my line, and it looks like this, right? Now that line, we can find the slope by looking at the graph. We can also find the slope by using the formula. And we're going to do both of that here. But one way to see the slope is, like I said, by counting it on the graph. So we pick our 2 points on our graph. You always want to pick 2 points that are in good spots, meaning they're on like the little crosshairs of your graph. And then we're going to count how much do we rise and how much do we run. So on this graph, I would rise 2, and I'm going to run 1, 2, 3, 4, 5, right? So we've got a rise of 2 and a run of 5. So then that means our slope of that line would be the rise over run. So it's 2/5. So one way to get your slope is by being able to put it on a graph and then counting that slope. How much does it rise? How much does it run? Another way to find our slope is we can use our formula that we just wrote down up there. So we've got m equals y2 minus y1 over x2 minus x1. And then we're going to plug in our point values. I think it's very useful here if you label your points. So my negative 2, 2, that's my first x value and my first y value. And 3, 4 is my my second x value and my second y value. So I'm just going to, once I have those labeled, I'm going to plug them all into my formula. So y2, taking it from what I labeled, would be 4 minus my y1 is positive 2. Okay, then our x's, x2 is 3. My formula says minus, and then my x1 is negative 2. So I also have to put a negative 2 there. You can't just put 3 minus 2. That minus is part of the formula, and then it's a negative 2. So you need the minus negative 2. Okay, and then if we do that math, 4 minus 2, that gives us a 2 on the top. And then 3 minus negative 2, that's the same as 3 plus 2. So that gives us a 5 on the bottom. So we've got our slope is equal to 2/5. Now notice that is a positive slope. And up here on top, it talks about a line with a positive slope, right? A line with a positive slope. If I start on the left side of my line and I go with the graph, that line is increasing, right? It's going up if we go from left to right. So think about how you read. You always go from left to right. We do the same on a graph. If I go from left to right on my graph, then a line that has a positive slope increases. Right? It goes up from the left to the right. It's like you're climbing up a mountain. You are increasing in your height, right? One other thing I want to mention is that if I have a slope, a positive slope of 2/5, I could also technically write that slope as m equals -2 over -5, because a negative divided by a negative would still give me a positive 2/5. So those two things are equivalent. So just make sure you understand that you could have both numbers negative or you could have both numbers positive. That's still a positive slope. Okay, all right, so there's our first example. Let's kind of do the same thing with our next one. So I'm going to start with plotting the points. So I'm going to plot the point 0, 0, and then I'm going to plot the point 3, -3, which goes right there, right? And then we'll draw our line. Oops, let's try to use the same colors here. And that goes that way, right? Okay, so now if we want to count the slope, we can do that. And just be mindful, you could go this way or you could go this way. It doesn't matter. And I'll show you why it doesn't matter here in a second. But if we did it, oh shoot, I just did get rid of that. There we go. Okay. If we did it from the first way I said, I would count my rise of 3 and my run of -3, right? So that would be a slope of 3 over -3. Now, I don't want to leave my slope like that. I can simplify that fraction, right? 3 divided by -3, that's just -1. So that's a slope of -1, okay? If you counted it the other way, if I go down 3 and to the right 3, that's a slope of -3, because I went down 3, over +3, because I went to the right 3. -3 over 3, that's still equal to -1, right? So either way, I get a slope of -1. And that's kind of like what we were talking about in the last one. If I've got a negative slope this time, right? So I had 3 over -3, or if I put -3 over 3, a positive divided by a negative, or a negative divided by a positive, either way, those would equal a negative slope, right? Okay, so then let's find our slope using our formula. So m equals y2 minus y1 over x2 minus x1. And if you want to label your points, here's our x1, y1, and our x2, y2. All right, and then we plug in the numbers. So y2, that's -3, minus y1 is 0, and then x2 is 3, minus our x1, which is 0. That would give us -3 minus 0 is -3, and 3 minus 0 is 3. And then if we simplify that, we get our -1. So our slope is -1. Okay, this time we got a negative slope, right? So if we go from left to right on that purple line on that linear graph, this time our line is decreasing. We're going down the slope, right? We're a negative sloping line. So this, as a negative slope, we hit it decreases. Okay. All right, so positive slope, increasing line, negative slope, decreasing line. Those things about like a -2 over -5 is the same as +2 over +5. or like the different ways you can write a negative fraction. Keep those in mind as you're working with slope. That matters. It's important. Okay, a few more here. These last two. Again, I'm going to plot my points first. So -1, 2, and then 3, 2. Now, if I plot my points like that, what kind of line is that going to make? That is a horizontal line, right? Okay, so if I was going to count my rise over run this time, how much do I need to rise to get to that point? I don't have to rise at all. There is no rise, but I am definitely running to get to the next point, right? If I'm going to go over to this next point over here. So this time with my slope, well, how much did I rise? I did a 0 rise, but I can run any number I want. I can go to whatever point I want to. In this case, if I went over to that other point we plotted, I went over 4, right? But it doesn't matter what number you put on the bottom there, because 0 divided by anything is always going to be 0. You're allowed to have 0 on the top, remember? And again, don't leave your slope as 0 over 4. Make sure you simplify that. 0 over 4 is equal to 0. Okay, to see this with the formula, if we do our n equals y2 minus y1 over x2 minus x1, and we plug in our points, we can label them again. Okay, so our y2 is 2, minus our y1 is 2, and then our x2 is 3, and our x1 is -1. So 2 minus 2, that's 0. 3 minus -1, that's like 3 plus 1. So we get 4, and 0 divided by 4 is 0, right? So our slope is 0. And as you can see from our picture, a line that has a 0 slope is horizontal. So every horizontal line, horizontally, I spelled that right. Every horizontal line has a slope of 0, right? We are able to run, we can move back and forth, but there is no rise, right? So I can run back and forth, but I can't go up at all. Okay, think of that like a flat ground, right? You can walk back and forth. Okay, next one, we'll again plot our 2 points to start. So 2, 1, and 2, 4. All right, those 2 points would make what kind of line? If I draw that in, that's a vertical line, right? Straight up and down this time. Okay, so this one, if we think about our slope, we do have a rise, right? I can rise to the other point. So my rise there, I went up 3, but how much did I have to run? How much did I have to go right and left? Well, I didn't go anywhere. I went 0. So our rise is 3, our run is 0. Now, at this time, I've got 3 divided by 0. Am I allowed to do that? No, you cannot divide anything by 0. So we don't get a number for our slope. 3 divided by 0, that's undefined. It doesn't work, right? So we've got an undefined slope here. All right, let's try this one just so you can see how it works with the formula. So y2 minus y1 over x2 minus x1. I label my points, x1, y1, and x2, y2. And we plug them in. So 4 minus 1 over 2 minus 2. That is 3 over 0, and that doesn't work, right? So our slope is undefined. Again, don't leave your slope as 3 over 0. That's not an answer. It is 3 over 0, but I need you to understand that 3 divided by 0 means undefined. That's an undefined slope. And just like horizontal lines will always have a slope of 0, vertical lines will always have an undefined slope. So a line with undefined slope is vertical. And you can think of this one, this is like climbing a rope. You can go up and down, but you can't go left and right. One way people like to remember that a vertical line is undefined is that you can't just walk straight up and down. It doesn't work, right? If I was standing on the ground, I could climb a rope, like I just said, but if I was standing on the ground, you could not walk straight up. So that's one way people like to remember that a vertical line is undefined, because I can't just walk straight up a vertical line. It's not going to happen. That's one way to remember it. Okay, so there's our basics on slope. Horizontal and vertical, you've got zero and undefined. But more often, we will talk about an increasing or a decreasing slope. Got positive and negative slopes. So your homework today, you're just going to try out looking at some graphs, counting your rise over run, and then simplifying your slopes. You're also going to try out some problems where you are given a couple points and you have to plug them into the formula to find your slope. Again, always make sure you simplify that fraction. So if you get like 6/8, right, don't leave it as 6/8. Those are both divisible by 2, so I should say my slope is 3/4. Okay. If you get -2, or let's say this way, you get 2 over negative 1 as your slope. Don't leave it as 2 over -1. That's just -2, right? Simplify your numbers. That makes it much easier on yourself later. Okay. Your homework today is going to be on delta math. So it'll be all online. You don't have to turn in a worksheet or anything. Hopefully that makes it a little bit simpler. You don't have to do any uploading or anything. So we'll go with that for a while and see if we can kind of do most of our homework on there while we're doing this e-learning thing. See if that makes it easier. Well, let me know if you have any questions still on the delta math, if you're having any problems getting to videos or anything, and best of luck to you all.